Okay. All right, thank you. So let's see. Oops, perfect. Okay, so I'm going to speak today about a few ways that robotics is actually reinventing some pretty established industries. And I'll use as one of the examples how we're using robotics to reshape the sort of entertainment products you can make and how we're actually bringing an animated character to life. I'll start with an industry that's very familiar in terms of robotics innovation to everybody, and that's transportation. So autonomous vehicles are now the hottest space around. Everybody's familiar with how almost every single company is chasing these sort of technologies. But what's interesting is to look back at how quickly that innovation happened and how just over 10 years ago, it was a completely different landscape. And this is actually a really great example of how robotics can come in a very short time into a space and completely turn things upside down. So a little bit of history. What most people would consider an inflection point in autonomous driving was actually in 2004. There was something called the Grand Challenge, which was a competition sponsored by DARPA, where they had a $2 million prize for the first team that could navigate a 130-mile course in a desert, completely autonomously with no humans. It was a fixed course, no moving obstacles, but they had to do it on their own. And there were a bunch of entrants, universities, some companies, and the team that got the furthest was this entry, Sandstorm from Carnegie Mellon. It got about 7.5 miles in before it flipped over a boulder and busted that really expensive looking sensor there. So, but it was considered a pretty big breakthrough at the time. And just the very next year, they redid the challenge, and that time 4 teams finished, 2 from Carnegie Mellon and a winning team from Stanford were among them. And 2 years later, there was an urban challenge in a suburban environment with traffic lights and moving cars, which again, multiple teams finished. And just a few years after that, all of these projects became the precursors for the Google Autonomous Car project, which as we know was kind of was the front runner before a lot of other teams got into space. And it's pretty incredible because back in 2004, nobody would have predicted that within 10, 12 years, we'd be at the stage that we are at today. And now we have on the order of 40 to 60 companies that have legitimate efforts to trying to make autonomous vehicles. But what's interesting is most of the companies you would consider the front runners into space aren't the traditional automotive companies. It's actually very software-driven companies from places like Silicon Valley. And I'd even consider Tesla in that category because they're one of the few automotive companies that have really treated an automobile as a majority software problem, not just a hardware problem. And so it's a really great example of how in a short amount of time you can have an established industry get completely flipped upside down with technology and DNA that typically isn't found within that industry. And when you look at the rest of consumer spaces, one of the big catalysts of innovation in other consumer categories is actually the price of a lot of components that have been impacted by the mobile phone industry. You look at the last couple of decades of mobile phones and the last decade of smartphones and tablets, and you've had incredible price pressures on things like microcontrollers, cameras, wireless chips, batteries, motors, all these sort of things that when you ship units at multi-billion unit quantities, you suddenly have capabilities under $1 that you would never even dream about even a few years earlier. And so if you have the right kind of creativity and combinations of systems that you put together using these components, you can do some pretty impressive things. And so for us, when we started Anki back in 2010, we wanted to approach the entertainment side of robotics and create products in the toy and gaming and entertainment space as a starting point for broader innovation within consumer robotics. So we started with a battle racing game called Overdrive. This is basically a racing game where each car is a robot. You control them with smart devices, but whichever cars you're not controlling, they drive themselves. And there's virtual characters that become the drivers of those cars. They trash talk with you to tell you how you're inferior as a driver. You have weapons, special abilities. You're effectively playing a video game in the real world. And the goal was truly to make it possible to program games on top of these physical characters. And so when you look inside of this car, what's interesting is that you have 50 megahertz computer. Again, less than $1 because suddenly a computer that used to cost gigantic amounts of money has been pummeled by the mobile phone industry. You have an optical sensor that's basically the front-facing camera of an iPhone. You have these systems that are scanning environment 500 times a second where the cars can identify their positions and send that back to a mobile device. And in effect, we have a video game inside of a phone that's synchronized to the physical world. And so we can effectively program these games on top of these characters and do things like have weapons, special abilities, high levels of AI, and bring all of these digital elements to life that you would typically not expect. And so this was a starting point, but in parallel, we were working on underlying technologies that would let us go a step further. And our goal was to actually bring a physical character to life. And so this is where I'd like to introduce Cosmo. What we wanted to do was to bring to life a physical character with a level of personality and emotional depth and behavioral intelligence that you would never see outside of a screen. So if you literally think of the beautiful characters that you remember from Pixar movies and DreamWorks movies, we asked the question, what would it take to bring a character like that to life physically, where not only would it have a level of emotional richness and intelligence beyond anything you'd expect, but we could actually use robotics and AI to make those emotions relevant to what's happening around it. Things like face detection and interaction, understanding of the environment, being able to play games, being able to have the right emotions at the right time, evolve as a character. And so we wanted to make this little robot come to life and in effect be this like mischievous little newbie of a robot that wants to be a superhero but isn't quite there yet. And your goal is to kind of play with him and evolve him. And in the process, all of the emotional cues and opportunities to show off his intelligence end up being far more powerful physically than they ever would virtually. So I'll show a little clip that gives you an idea of him and his personality. All right, so that tells you all I need to know about Cosmo. He's a fun little guy. But what's really fascinating is how he's actually designed. And this is where one of the most important realizations that we had took us a little bit of time to get there, but we realized we had to approach Cosmo as a character from a film. And so we literally built an animation studio within a robotics company that's animating a physical character in the real world. So when you have a situation like this where Cosmo's waking up off of his charger and kind of coming out into the real world, this is a rendered version of what happens, but it matches exactly what happens physically. And that's because we use the exact same tools that you would use for animating a character in a film. We actually use a program called Maya, which is one of the main programs used for animated film. We have a rigged up version of Cosmo, an eye engine, sound engine, all of the motor capabilities that match his exact ranges of motion. And our animation team actually animates Cosmo exactly like they would have animated him if he was a digital character, except that the output is actually spliced to the physical world instead of digital. And so what this allows us to do is to approach Cosmo exactly the same way an animation studio would approach the development of a character in a film. We think about his backstory, his motivations, what makes him tick, what gets him excited, what's he scared of, what makes him insecure, what's his long-term goal, and how does he build relationships with people? How would he react under every single type of circumstance? And so we have sketches, we have storyboards, we have backstories, and the really unique thing is that the robotics and AI is the layer that ties all of these digital elements with the physical world by allowing us to understand everything that's happening to where the emotions could make sense, but also knowing the right time to spawn them. And so we have a behavioral and kind of character engine that actually takes the stimuli from the outside world and generates the right emotions in real time. And so what happens under the hood that enables this is actually a lot of pretty interesting systems all working together. So from a technical standpoint, Cosmo is about 320 components. So there's microcontrollers, cameras, IMUs, motors, gyroscope, accelerometers, all sorts of gears and joints. Really, really sophisticated actually, and almost no empty space inside of him, where getting all these things to work within such a small cavity was quite challenging. But when you combine it all, you have a pretty interesting system that uses computer vision, uses these all these overlaps of technologies, and you end up having almost this triangle between character and animation from kind of a film-like approach, the game design side where you want to bring the interactive elements to life, and then the robotics and AI which enables it and in some sense embraces the constraints of the physical world. And this is where one of the most interesting challenges comes in, because when you are animating a film, you have a story on rails. You directly think of exactly what you want to happen. You work for years on a 90-minute film, and you control every aspect of that experience. In a case like this, you actually have to have something that's very interactive and intelligently responding to the environment. You have to be able to realize that you're going to encounter the same situation 200 times. You might be interrupted, you might get picked up, you might get tossed around. And the challenge is in making all these systems come together and create a character that, for lack of a better way to say it, feels like he's alive. And that is, in the end, the goal. And what's really fascinating is that all of these tools that go into making this one character, it's not about Cosmo, it's about the ability to animate physical characters and to bring these characters and stories to life. And so you can imagine different characters with different personalities, different background stories, different purposes, all existing with the same framework that allows this to happen. And over time, you can even imagine functional layers coming on top of it when the capabilities of these characters start expanding beyond just entertainment or companionship. And so we're really excited because we have a really rich roadmap ahead with Cosmo, and in fact, even from a developer standpoint, there's an SDK that's been used by universities to teach courses in robotics and to do research in areas like autism and human-computer interactions and computer vision and other areas. But more broadly, hopefully this is another example that helps you understand how robotics isn't really a particular industry. It's actually a tool that can be applied to almost any other industry to completely reshape the sort of products that are possible. So just like the internet was a tool that forced every single industry to rethink in the way they do business, and some were impacted more than others, robotics allows us to really rethink the levels of physical intelligence and autonomy that are possible. And what's most powerful about this is that it's so deeply tied in to the landscape of hardware ecosystem, mobile phones, smartphones, technologies, cloud AI, all these different elements, that it'll be a series of innovations and transitions that happens over the course of a number of years. And most of the time, these will happen from the outside because the incumbents in most of these spaces are actually not in the best position to completely rethink how they make products in the space. The sort of products that you see from us typically would not come out of traditional toy companies, just like an autonomous car would not have independently come out of an automotive company without a push from the outside. And so so hopefully this gives you a little bit more of an appreciation on how these technologies over time can actually lead to some pretty exciting innovations in spaces that go far beyond the ones that you would initially think of. Thank you very much.